Hi, hello, hi everybody. Great to see you. Great to have you in the stream. And today will be an interesting topic because I want to explore the Canvas API a bit more because obviously it's not anything that would be new, but it's new to me. I have not really worked with it at all. I guess not at all, almost not at all. So it's something I have way too little experience in. So I want to explore it today, play around with it a bit, and I figured why not see if some other people are interested in that. I also see there's one, let's call it a question in the chat. After the last human coder is replaced, will YouTubers continue to make content for LLMs to watch? Well, I understand this is not serious, but coders will not get replaced anytime soon, so I don't think that is really something we have to care about. Yeah, but I will say, we definitely are already at the point where a lot of the written content, the text content on the internet is primarily consumed by bots and AI. So, excuse me, there's that. But I'm confident that videos will still be consumed by humans for the foreseeable future. So, and with that, without further ado, let's actually dive into the Canvas API. And I'll say it right away, this will be kind of maybe a bit of a weird stream because, as I said, I have very little experience, pretty much no experience with the Canvas API. So we'll learn together, or maybe I'll learn from you, and we'll see. By the way, in case you can't stick around all the way to the end, just like all my live streams, I will upload the recording of this live stream tomorrow on my second YouTube channel, Maximilian Schwarzmüller Extended. Got all my past recordings there, and this one will be no exception. So, the Canvas API. What exactly is the Canvas API? It let's see what MDN says, shall we? The Canvas API provides a means for drawing graphics via JavaScript and the HTML Canvas element. And that I knew. So that's something I knew, that essentially it's an HTML element we can draw on programmatically, and we can build all kinds of fancy stuff around that Canvas API. We could, of course, also try to build an application where the user of the website can draw, and we then just technically draw those strokes, and we can save them. We can build all kinds of crazy stuff. And I mean, there are sites like XCaliDraw. This site here where you can draw, that is, if you open the DevTools, that is using the Canvas API. So if we dive into the DOM tree here, if we expand that, come on. Here we got a canvas, and that is, you see, if I hover over that, that is everything essentially. That is what we're drawing on. Now, what's important to understand though, the canvas, as you will see, is not something you just put into a website and your users can start drawing on it. Instead, it's you and your code that draws something onto it, and then you can build applications like XCaliDraw by basically watching what the user does with their mouse, and then you can translate that into what's visible on the screen. But yeah, we'll explore everything related to that. A couple of questions. How are you? I cannot stay for the full stream today, having a presentation of the Bachelor of Science half an hour before the end of your stream, so we'll stay for as long as I can. That's awesome. So nice to have you on board. And as I just mentioned, you can watch it tomorrow if you want to on my YouTube channel. LLMs are already downloading this from YouTube and learning from it. Yeah, absolutely. Everything gets extracted and parsed by LLMs. I just don't think there will be a future where we create videos that are primarily consumed by large language models, because ultimately we create videos because of the interaction with humans. Obviously, because of the ad revenue and all that going away does not make it very appealing. Why did you change WebStorm for Visual Studio Code? Mostly because it's faster. Because it was faster and it got so feature rich. It had everything I needed, so that's why I made the switch. Also because it's free, of course. Currently, I'm taking React Native course. I must say, full of interesting and practical stuff. I'm loving it. Awesome to hear. Thank you so much, Enemy Killer. That is amazing to hear. I hope you'll get a lot out of this course. And yeah, greetings to everyone who tuned in. So back to the canvas. Excuse me, I was a bit sick the last week, so I still got that cough. Yeah, so back to the Canvas API. Now, of course, I don't just want to read through that article. I guess that would be rather boring. But I will use MDN and this article here as a source to learn about it. I guess what's interesting is that the Canvas API, as they mention here, largely focuses on 2D graphics. And then there's the WebGL API, which uses the Canvas element 2, but then draws hardware-accelerated 2D and 3D graphics. And we'll see if we also get into that. So I'll create a basics folder in there. And in there, I'll just have an index.html file and an app.js file. I will keep it very simple, or actually almost simple. Let's delete that. I want to have a hot reloading web server. So what I will do is I'll create that basics project with Vite, but I'll use vanilla. Sure, I guess we can use TypeScript so that we can got some convenience features. So I'll delete that counter TS file. I'll delete that import in main TS now, delete that. And then here, I want to render my canvas element like this. And remove setup counter. Okay, so and now with that, I got my dev server running on localhost 5173. So if I open that, I don't see anything on the screen. I don't see anything on the screen because I'm only rendering a canvas, and out of the box, that is not visible, or yeah, doesn't give us anything. So of course now let's say I go into my style CSS file and remove some styles there like this. If I go to my canvas, and I give it a width of, let's say, 10 rem and a height of 10 rem, and I reload, still nothing there. If I open the developer tools, though, I can see my canvas. It's here, and if I hover over it, you can see it here on the right. So it is there, it's just not visible. And actually, let's make that way bigger. Yeah, so I guess what we can do is give this a little background color, white. And now we can see it. Actually, now it's too big, so let's go for 50 rem. Here it is, here's my canvas. And I'll also give this margin auto, or margin 5 rem auto. And why is it not centered? Because my body has this, I guess. Hello. I mean, it's not too important. Oh, there is this div around it. Yeah, but why? Well, let's do it differently. Don't really want to waste a lot of time on that. Let's say this is display flex. And then we got justify content center. I wonder why am I not getting any completion from cursor here? Yeah, so now this is centered. Awesome. Okay, we can get rid of that. Perfect. So here's my canvas now. Here's my canvas. And now I want to interact with that canvas. And as I mentioned before, we do that with code. So we get a hold of the canvas And now the new stuff starts. I knew that we need the canvas element, but interacting with it, all that stuff is brand new to me. So we want to get a hold of it. Then we seemingly get a context, a 2D context. I wonder if we can also get other kinds of context here. And then we can fill that context and draw a rectangle. So that's interesting. Let's take a look. So here I got my canvas. That looks good to me. And now cursor is basically giving me everything here. But I want to go step by step here. Now, first, which options do I have here? Okay, I got 2D, WebGL, and WebGL2. So we saw that before, that we can also use WebGL to draw onto a canvas element. I wonder if WebGL means 3D and WebGL2 means 2D. But for now, we'll start with 2D. So now let's see, what do we have on that context object? So we got a bunch of stuff. We can begin a path, we can close a path. I guess we can then also like add points on that path, would be my guess. We can draw an ellipse, we can fill something. I don't know what we pass here, but we can also fill a rect. And there we need an X and a Y coordinate and a width and a height, and that makes perfect sense. So if we say 10, 10, 100, 100, if I save that, okay, we got a black rectangle, and interestingly, those edges are a bit blurry. Not sure if you can see that, but those edges are a bit blurry for me here. Not sure why that's the case. But maybe we'll find out. So that's what they are doing here too, and I can change the color by choosing or by setting fill style. So whenever I get a context, my understanding is I'm starting to manage to potentially draw a new object. So I could name this rect, and say rect fill, what was it? Fill style. Okay, so I got the fill style, I got the stroke style. So let's do that. Let's say stroke style is black. Then I got the line width 10. And if I save that, well, that's not what I would have hoped for. Do I need to do that before I draw it? Okay, interesting. So now it's red, but the stroke style is not being applied. I wonder, do I need to call? As I mentioned, I have no experience with that. I don't know if I need to call stroke to apply a border, essentially. Does not look like that's the case. Or if I need to call stroke rect, and now I drew a rectangle again, but only the outline. But how do I draw a rectangle with an outline? Maybe we'll learn along the way. So we got a comprehensive canvas tutorial here. That sounds like a good entry. This tutorial describes how to use the canvas element to draw 2D graphics. Yeah, that sounds good. Canvas is an HTML element which can be used to draw graphics via scripting. This can be used to draw graphs, combine photos, create simple animations. Let's take a quick look at the chat. What is the best stack for a small MVP these days? So, depends obviously on which languages, which programming languages or libraries you know. Next.js is pretty popular for a reason. Large language models and AI knows it pretty well, so it can help with that. And I guess you can get a lot done with that. So Next.js is not a bad choice. I personally, I'm playing around quite a bit with 10 stack start right now, essentially. And I like that a lot. Documentation is not that great, to be very honest. It's really hard to navigate, but it's a fun framework. But other than that, of course, Laravel is amazing. Super well documented, established. So yeah, I guess these are all good stacks. Used to be a Flash developer. I remember learning all the Canvas API after hearing Flash was doomed. Yeah, I never got into the Canvas API, so I finally felt like maybe I should at least understand some basics about how to draw rectangles and stuff and how to maybe react to user input. Hi Max, I'm doing your Flutter course right now. Great thing. Do you learn this all, or is this just a hobby? No, it's not a hobby. So I create courses, of course, for a living, but I also work as a developer. So that is not my hobby. I will say though, I started programming as a hobby around the age of 13 or 12. I don't remember exactly. I used to do that only as a hobby, but nowadays it's more than that. Yeah. So let's dive into that tutorial. Basic usage. So we got a canvas. Yeah, I have a width and a height with assigned with CSS. I wonder if it makes a difference. I think it won't. The element can be sized arbitrarily by CSS, but during rendering, the image is scaled. Oh, okay, so width and height are important. If the CSS sizing doesn't respect the ratio of the initial canvas, it will appear distorted. Oh, that explains the blurriness. Very interesting. So what I want to do here is I want to set width height 500 or something, and then I want to do that here too. Yeah, and now the blurriness is gone. Okay. Well, see, that's why we want to go through tutorials. Because we learned, or I learned, that CSS styling alone is not enough. I should set width and height and keep that in sync with my CSS styles. Okay, the idea, yeah, we got that. Accessible content. The canvas element like image, video, and so on must be made accessible by providing fallback text to be displayed when the media doesn't load or the user is unable to experience it. So how do we do that? Providing fallback is very straightforward. Just insert the alternate content. Okay, so for accessibility reasons, it's recommended that I output something here. Probably something that's more helpful than that. Okay, yeah, so we got that. The rendering context. The canvas element creates a fixed size drawing surface that exposes one or more rendering contexts, which are used to create and manipulate the content shown. In this tutorial, we focus on the 2D rendering context. Other contexts may provide different types of rendering, for example, WebGL. Yeah, okay. Canvas is initially blank. We have get context to obtain the rendering context and its drawing functions. Get context takes one parameter, the type of context for 2D graphics, such as those. Okay, yeah. I wonder, and I guess I'll see and I'll learn, if I draw multiple elements by getting the context multiple times, or if I start drawing a new element whenever I called fill rect, for example. So I guess I can try that. If I rename this to CTX, and that of course stays fill rect, and I draw another rectangle in a different position, and I make that blue, and of course stroke style and line width didn't do anything, so I'll get rid of that. Okay, so that's how I can draw them all. I draw an element with a fill, rect, and so on command, and then I can start drawing more. Okay. It's kind of not super intuitive for me, but yeah, I guess makes sense. Or it is what it is. Okay, minimalistic template, don't need that. Simple example, fill style, fill rect. Yeah, so they're doing exactly what I did there. Drawing shapes. Now that we have set up we can get into the details of how to draw on the canvas. the grid. Before we can start drawing, we need to talk about the canvas grid or coordinate space. Our HTML skeleton from the previous page had a canvas element 150 pixels wide and high. Normally 1 unit in the grid corresponds to 1 pixel on the canvas. So my canvas is 500 by 500. So 0, 0 would be in the top left corner. 10, 10 is a little bit shifted further down into the canvas. And 500, 500 would be all the way in the bottom right. So the rectangle is outside of the canvas, I guess. So 400, 400 should actually position the rectangle in the bottom right corner. And it does. Got it. Unlike SVG, Canvas only supports 2 primitive shapes, rectangles and paths. Oh, okay. So I saw there also was an ellipse, but I guess that's then just a path that's filled somehow. All other shapes must be created by combining 1 or more paths. Luckily, we have an assortment of path drawing functions which make it possible to compose very complex shapes. Let's look at a rectangle, fill rect, stroke rect, clears the specified rectangular area. Oh, okay, so I could actually say, that's interesting, clear rect. And let's say I start a rectangle, let's make it a bit bigger, here at 150, 150, this one. And now if I clear a rectangle at, let's say, 200, 200 for 100, 100, I cut out a rectangle. That's my expectation. Yeah, and I do. That's interesting. So that's how I can draw a bit more fancy shapes. And I mean, ultimately, you could draw the outline of a rectangle by making the cutout a bit bigger and shifting it like this. Interesting. I don't think human coders can be totally replaced. AI is great for basic tasks, but more specific tasks, it would require human guidance. Yeah, I agree. And I've talked about this in other videos before, which is why I don't want to talk in length about it now. Watching your React tutorial, and it's awesome. Quick question. When I try to learn a new library, I get overwhelmed by the documentation, content, and TypeScript code. What approach should I follow? Step by step. It's easy to get overwhelmed. I always recommend, as I do it here, when diving into something for the first time, start simple with super simple, stupid examples and practice work like this. And then over time, as you get better, start building projects that get more and more complex. And that's the best way to learn something, in my opinion. Could you please tell more about your new tool for coding? Does it worth to switch to? You mean Cursor? Cursor is pretty good. Cursor is, of course, that well-known AI IDE, I guess, and I like it quite a lot. I use AI quite a bit for coding, and I like Cursor a lot. Are you interested in doing an HTML5 games like you're using Phaser.js or Excalibur.js eventually? So I will say I'm super interested in getting into game development, but probably not HTML or web first. I would love to get more into the Godot engine. But I do want to I want to understand what I can do with the Canvas API and how I could leverage that in future projects to maybe do certain things I wasn't able to do before or do certain things in a better way. I really just want to explore that because I never did before. Do you think of switching from web dev to a system developer? So I did start to learn Rust 2 years ago, but not primarily because I wanted to get into systems development or anything like that, but because I find that also interesting. But I don't plan on switching away from web development because as a web developer right now, with AI, you can get so much stuff done, and web development, just like mobile development, are the areas of development where you can build your own projects, publish your own projects, you can build SaaS products. Of course, it's not easy. Of course, the marketing is hard and so on, but you got so many. I don't see any other area in development where it's so easy to start your own thing because you write code that's directly facing your customers in the end. Not the code, of course, but what you render with that code, if you want to put it like this. So yeah, that's why I don't plan on switching away. Oh, yeah, and I know that many developers are pushing AI tools on developers, whether the devs want them or not. I'm totally aware of that because whilst you are of course correct, I'm self-employed, so I don't have a boss that tells me to do something. I of course have friends. I of course have other people I talk to, and I'm well aware of how annoying it is if someone that doesn't know what you do comes to you and tells you, hey, use that tool and I'm sure you can get that task done in 1 day instead of 3. I totally understand what you mean, and I'm well aware of that fact. Okay, so let's continue diving into the Canvas API. Each of these 3 functions, yeah, we saw those. So here they're doing what I did. They draw a filled rectangle, clear it to cut out a part, and then have a stroke. And I wonder if I want to have a stroke around a rectangle, I could just say stroke style black, and then stroke rectangle. Maybe like this. No. Okay. Wait a second. I would need to start at 150, 150. So now the stroke is here at the border. It's a bit hard to see. Let's maybe make it red. Okay, it's still hard to see. Let's make it thicker. Hello. Yeah, okay, so that is how I can add a stroke around a rectangle. Let's make it black again. And let's make that rectangle let's make it green. Okay. And yeah, it's ugly what we're doing here. Seeing blurry edges. Yeah, I fixed that. So where are we? Now yeah, so that's all the styling. Image rendering pixelate. Okay, I should probably read that. You may notice that the shape's edges may appear blurrier. This is not because okay, so it's a different issue. No, but then we scale it up with CSS. So when the width and height deviates from what we do with CSS, we get blurriness. But we can set image rendering pixelated. So that allows me to have differences. So if I go to, let's say, hello, to 800. Okay, so that's how I can scale it without the blurriness. If I remove image rendering pixelated, yeah, it's a bit blurry. It's probably not visible on the stream, but the edges are a bit blurry. And if I bring that back, they're crisp and sharp again. Okay. But now we got another issue. Oh no. One that you can actually also observe in the original rectangle example. The stroked rectangle is not only 2 pixels wide instead of 1, but also appears gray rather than default black. What? Oh. This is because of how the coordinates are interpreted as shape boundaries. If you look at the grid diagram above again, you can see that the coordinates do not identify a pixel, but rather the edge between 2 pixels. Okay. In the images below, the grid represents. If you consider a path from 3.1 to 3.5 with a line thickness of 1.0, you end up with the situation as second image. The actual area to be filled only extends halfway into the pixels. To fix this, you have to be very precise in your path creation, knowing that the 1.0 width line will extend half a unit, creating ends up completely. Okay, I have to admit this is not entirely clear. Whoops, not entirely clear to me. I understand that we can run into problems with our grid when using the wrong values for drawing. So if I copy their example, if I copy that, now I got a black rectangle in the top left. Yeah, but it's still black. Well, I'll revisit this when I see some strange behavior. So, okay, now they're also starting to draw, or did they do it before? They're starting to draw lines? No, I don't think so. Besides rectangles, we can draw paths by beginning a path, by closing a path, and by calling fill. And in between, we have line 2. Okay, so let's do that. CTX begin path. Do we have coordinates there? No. And then, oh, I just saw. And then we can move to, and we have line 2. And I guess move to moves the point where we then start drawing a line. Let's check this. So if I say line 2 without move to, and I say, let's actually comment out those rectangles. And I then say close path. Close path. Yeah, I don't see anything on the screen. If I add another line. Oh, I also need to call fill, of course. So let's call fill. Still nothing there. If I move, though, if I move to 100, 100. Also nothing. Why is that? Begin path, move to line to close path, fill. Begin path, move to line 2. So let's maybe do that. Line 2, close path, fill. Why is there nothing on the screen? Let's copy that. Okay, now there is. I don't fully get what the difference is. So if I move to, let's say, 100, 100. So I only changed the first setting here. So now we are, whoops, we are here. That's where we move to. This point, I would say, is 100, 100. Okay, so, and now we have a line to 100, whoops, to 150, 150, and let's actually comment out these two. Okay, so now we don't see anything. So we can't draw a line. Oh, I see. I'm calling fill, and I can only fill it if I have a shape that can be filled. I'm drawing a line here, though. I need a third point to be able to fill something, I guess. So now if I have 120, 120 here, now that should be a triangle. Okay, that was my theory. Does not look like that's the case. Let's draw another shape. Okay, that makes no sense to me. I thought the problem is that fill only makes sense if there is something to fill, and there is nothing to fill if I only have like a starting point and then a line. But now I'm continuing to draw this, though. Do I need to be careful? So they start, or they move to 3, 2. Then they have a line to 9. So they start at a certain point. Then they have a line. Then they have a line. I wonder how these things work together. Yeah, got a stroke. I'm not sure if I have to call stroke because they're not calling stroke here. That's what I'm struggling with. So if I, again, copy that, and then maybe I multiply that with 10, all these values. Let's see if it then works. Okay, that works. Yeah, it's possible that I was not careful enough with where I was drawing to. So again, move to 30, 20. So that is, I would say, this point. So we have 30, we have 20. Makes sense. Then we draw a line 290, 45. So that should be this point here, I guess. Because that makes sense is 90, that's probably 45. Then we draw a line to 65, 105. So again, makes sense that this is this point here. And then we draw a line to 580, but that's, oh yeah, 5. It's only this little bit here. Yeah, okay, so I picked some stupid lines. Okay, got it. So if I again try to draw to 100, 100, I haven't saved yet. I'll draw somewhere here. So 100, 100. I draw somewhere here. Then I could draw, I want to draw down, so I draw 150, 150. But then so I drew down, so I'm basically, I started, let's say here, then I went down to 150, 150. Actually, it's not that steep, but you get what I mean. I push it down a bit. And then I want to go back here, so I want to have X should be 100 again, if I say that this here is 100, but Y should be 200 or something like this. So 100, 200, let's say. And then I want to go to the left. So I say X is, let's say, 50. And then Y is also 150 again. Yeah, so now it worked. Okay, I was a bit off, but that is where I draw it. Okay. Human viewer here. That's pretty good. Human recorder here. Okay. I see. And I wonder now, I got some pixelation here around the edges. If that's the problem they were discussing earlier, that I would have to be more careful about which points I chose. Because if I copy their example again and draw another rectangle, no, but that has the same problem. It's also pixelated. Okay, so I guess it's not anti-aliased. So here they got these different rectangles. This phenomenon of partially filled pixels also extends to shapes that don't align to the pixel grid. A rotated rectangle, which we have here. But does it make a difference if I now disable image rendering pixelated? Oh yeah. Oh, I got it. So now it's blurry. And if I turn this on, it's not blurry anymore. Instead, it's pixelated, which I guess makes sense. Okay, got it. So we can all see it here. Blurry, pixelated. Okay. Drawing paths. Yeah, we already saw that, but let's see what they're saying about it. A path or even a subpath can be closed. To make shapes using paths, we take some extra steps. First, you create the path, then you use drawing commands to draw into the path. Once the path has been created, you can stroke or fill the path to render it. Yeah, so we filled it here. Fill. If I call stroke, on the other hand, yeah, I got just a stroke, which makes perfect sense. Begin path creates a new path. Once created, future drawing commands are directed into the path and used to build the path up. Okay. And then we got path methods. Okay, well, we'll get to them. But then we got close path to add a straight line to the path going to the start. Okay, so that I don't have to manually figure out where I have to move my line to. Stroke and fill. The first step to create a path is to call it begin path. Internally, paths are stored as a list of subpaths. Okay. The second step is calling the methods that actually specify the paths to be drawn. We'll see these shortly. Okay, yeah, that's line 2 and so on. So drawing a rectangle, sure, that there makes sense. And here they don't have close path because they close it manually by just drawing the right lines. I wonder what the difference between move to and line 2 is, but I'll guess we'll learn soon. Yeah, but here, so they start at 75.50, which I guess is this here. Whoops, this point. Then they move to 175, so this one. So they started here and then moved to this. Oh, fill also closes it, kind of, I guess. And then they move further to the right again, but not as far down. So this is the last point. And then by calling fill, this here gets filled. Okay. Got it. Moving the pen. One very useful function which doesn't actually draw anything but becomes part of the path is the move to function. You can probably best think of this as lifting the pen or pencil from one spot on a piece of paper. Okay, so that doesn't draw. Line 2 draws, move to does not. Okay, yeah, makes sense. So move to says, okay, we'll start here at this point, but we don't draw this what is it? We don't draw this line here. Instead, we just move there. That's what move to does. Got it. When the canvas is initialized or begin path is called, you typically will want to use move to define where we start drawing. And then we get some convenience functions here to draw an arc, for example. Let's play around with that. So arc takes an x-axis, let's say 300, and y is 300. Radius, let's say, is 50. Start angle and angle. Okay, let's see what cursor gives me here. If I now call stroke, okay, a couple of interesting things. One interesting thing is that this is still connected to my shape here, even though I called close path. If I comment this out, I got just the circle. If I comment this back in, I got the line again. And I wonder why that's the case. Because of stroke here? No. But I wonder why I see anything without stroke. If I fill this again, yeah, still I got that stroke that combines both. So that's not clear to me why I got this weird line here going on. I also wonder, regarding that circle, what happens if I change that start angle? Oh, I see. That simply means where we start drawing that. Okay. So what is that? If I use 0.1, if I ramp this up to 2, so I guess since the last argument is counterclockwise, let's say true. Okay, the default is clockwise. So start angle 2 means we start, I guess, here. Then we draw our circle. Yeah, and obviously that is math, that's pi times 2, because that is the circumference. So that's why 0 to pi times 2 gives us a full circle. What was that number again? That is the radius. So if I use 10, it's smaller, obviously. Okay, makes sense. You have to begin a new path. Thank you. Thank you very much. Okay. Didn't have to do that with the rectangles, but I guess I have to do it here because we learned before that only paths and rectangles are built in. So since I'm not drawing a rectangle here, I'm continuing with the path, which makes sense. Thank you so much for pointing that out, Michael. Why Canvas API so sudden? I suddenly felt like I want to learn a bit more about it because it feels kind of bad to not know anything about it. And I also got some fun ideas or some interesting things I consider building in the future. Let's put it like this. Where the Canvas API could be interesting. I also find sites like Excalidraw simply amazing, and it feels kind of bad that I would not even remotely be able to build anything like this because I don't know anything about the Canvas API. I can already tell if you do it all by hand, you'll have to do a lot of math to get those coordinates right, but thankfully we got large language models which are also not good at math, but which have learned all the common patterns and can help us with that, I guess. Just joking. But yeah, you can, of course, get some nice suggestions here if I just see what... Okay, okay, now that fills it, sure. Oh, as a side note, if I set this to red, I get a red, yeah, circle makes sense. Okay. So here we are drawing two circles. Two triangles, not circles. Filling and stroking, got it. Arcs, to draw arcs or circles, we use arc or arc2 methods. I find the tutorial quite interesting because they start using something and then they explain it way later, but okay. Arc and arc2 draws an arc with the given control points and radius connected to the previous point by a straight line. Draws an arc which is centered at xy. Okay, so how does arc2 look like? Begin path. And then I want to have CTX arc2. Let's see what that gives me. Let's... Oh, that's outside. But why? Draws an arc with the given control points and radius. Oh, that's x1, y1, x2. Oh, okay, but still. Why do I not see anything with arc2? connected to the previous point. Maybe I need a previous point. So let's move to 10, 10. Okay. But isn't that just a regular line? Don't fully get what arc2 is meant to do. Angles and arc functions are measured in radians, not degrees. To convert degrees to radians, you can use the following. So that's radians is pi divided by 180 times degrees. Okay. The following example is a little more complex than the ones we've seen before above. It draws 12 different arcs, all with different angles and fills. Yeah, okay, we're drawing a nice pattern, Bezier, and quadratic curves. The next types of paths. Close path, you mean? Doesn't really change anything. Let's fill. But that is not a good idea. Let's go back to stroke. How to make that I could move fast between screens? Well, that's just on the MacBook, just swiping left and right. No fancy feature. Will I dive into D3? Yeah, also very interesting. D3 is definitely also interesting. And 3JS is also interesting. All very interesting features, libraries that I have way too little experience in, I have to admit. Yeah, we could draw a grid. Move to begin path, arc2. So let's say begin path, move, arc. Oh, wow. But something's happening. Yeah, so we got an arc. Now let's move that. So clearly that is the arc we're drawing here. Move to 1010 is this point. So if I remove that, we start here at the end point of our circle. And then we do arc 2. I just don't fully understand. Is this like a curved line? Is this meant to be a curved line or something like that? Reverse them. Well, not sure. I mean, I see the kind of, no, I don't understand what the difference between arc 2 and line 2 is. I would imagine that arc 2 is kind of curved. What if I use 200, 300? No. What if I have smaller values here? Yeah, I don't get it. Like a bridge between existing points. Okay. Okay, got it. Here we got curved lines, I see. with Bézier and quadratic curves. Used to draw complex organic shapes, yeah. Quadratic curve 2, Bézier curve 2. Draws a quadratic Bézier curve from the current pen position to the end point specified by x and y using the control point specified by CP1x, CP1y. And then we got Bézier curve 2 draws a cubic Bézier curve from the current pen position to the end point, also control points. So it's the curvature is the difference, right? The difference between these is that a quadratic Bézier curve has a start and end point, the blue dots here. So essentially here, and just one control point. And the cubic Bézier has two control points, and that, of course, allows us to bend it or skew it in all kinds of directions. So if I, again, just move to, let's say, 100, 100, and then I say quadratic curve to, sure, let's use that. Now I got a nice curve because I'm moving to 200. No, sorry, I'm moving. What is this? It has the from the current pen position to the end point specified by xy. So these are the third and fourth argument. And then we got the control point. Okay, so got it. So we move to 300, 100 from 100, 100. So we start here, and then we move 300 to the right, 100 down, so same level on the y-axis, but way further to the right. But instead of drawing a straight line, we have this point here, which is at 200, 200. So here, here. Makes sense. You should visualize the control points. So I could, I guess, draw well, I could draw an arc. My control, whoops, I did not mean to do that. A little filled circle, I guess. So I would want to have that at, not arc 2, I want to have arc. So arc was at 200, 200, radius, let's make it very small. And then like this, fill style red. Oh, and I have to close the path. And it's also filling this. Do I have to call fill like this here to make sure it's not getting filled? No. Why is it also filling the other element? Move to stroke close path. Why is this fill here? Do I have to also call close path here? Maybe here? Like this? Not sure why I'm filling that. And why is my circle? I personally thought the W3 School's Canvas tutorial was much easier to understand. Yeah, the MDN one is a bit tricky, I will say that. But then again, I haven't worked with it at all before. So I'm not sure why I'm filling this thing here and why my circle is down here. If I do 100, 100, it's here. 100, 200. Oh, so I need 200, 150. Now it's here. Still not sure Try begin. Oh, I need to begin a new path. Thank you so much. That's very helpful. Thank you very much. Okay. And I guess I know what the control point is not on the path. The control point is outside the path. So if I draw the control point, which is 200, 200, if I draw that here, then actually it's outside because it's not on the path. Instead, this is pulling this down, so to say, leading to this curve. That's how I understand it. Yeah, you can see it here too. The control point is not part of the path. Yeah. So yeah, thanks so much for telling me. Now I understand. We begin a path, we close a path, we start a new one, and the arc is part of a path. It's not a standalone object like a rectangle. So just to make sure I got it right, if I call fill rect on the other hand, then I actually don't need to, I actually don't need to call begin path or close path, because initially in the MDN docs they mentioned that a rectangle is a standalone thing besides a path that I can draw. Yep. Okay, here we go. So that is that control point. Got it. So now I'll copy that and I'll draw that Bézier curve. And that Bézier curve had two control points. Control point 1, x and y, control point 2. So what I want to do is I start at 100, 100. So I want to put control point 1, let's say at 150. So just a little bit further to the right, maybe 130. And let's not pull it that much down. Let's say we do 150 here. And then we got control points 3 and 4, 2 and, yeah, the second control point. And this here is my start and end, right? So that is x and that's the endpoint, the x and y of the endpoint. So I want to have that a little bit to the left, or actually let's do it a little bit to the right of the endpoint. And then, yeah, let's do 150 here too. Yeah, so that's what I would have guessed. So now it's actually pulled, if I zoom in here, you can see, actually I'll make that a bit clearer. Let's pull it way further to the right. You can see, theoretically, that would be where the thing ends, but then it's pulled over here because my control point is probably somewhere over there. So it's pulled, or probably a bit further down, like here. So it's pulled towards that point. Okay. Okay, so yeah, that makes perfect sense. Actually, let me draw these control points with some rectangles. So we got, we got 130, 150 for the first control point. And then for the second one, we got 390 and 150. Let's make those blue. Why is the first one not blue though? Fill style. I'm not quite on board with the colors yet. That's something I don't fully understand yet. So I don't think I need to call begin path and close path here, right? I don't think I need to do that with a rectangle. Well, it did change something. So begin path makes sure that this doesn't get filled blue, which makes sense. I don't want it to be blue. I want that rectangle to be blue. Do I need to do that before I call? Oh, before I call fill rect. Got it. So I could, I guess. Yeah, and I don't need to call fill, right? I only had to do that with the path. I see. Okay, and stroke after close path. Okay. American Dream, thank you so much. That is amazing to hear. Means a lot to me. I hope you got a lot out of these courses. Really amazing to hear that you're on board of a lot of those courses. And yeah, I hope that you find streams like this also interesting. So yeah, thank you so much for joining and for the very, very nice words. Means a lot to me. Thank you so much. Yeah, so here we got the Bezier things. Okay, we can draw speech bubbles. I don't feel like, I could copy and paste it, of course. I don't feel like doing the complex math here to draw shapes like this, but I get the point. I get the point that we can draw curved paths with Bezier and quadratic curve. Yeah, rectangles, we saw them before. Again, it's kind of weird that we used something and now we learn about it, but yeah, rectangle looks pretty simple. We got top left corner, width and height, makes sense. And then we can combine stuff. We can call clear path to cut stuff out. Well, what are they drawing here? Oh, wow. Yeah. Okay, shapes with holes. Yeah, we saw that before, that we can... okay, they are drawing another shape inside of it, which is then a cutout. Alternatively, we could use clear rect, I guess. For pixelation issue, as you use Mac Retina display, you have much more real pixels. Viewport pixels. Yeah, I'm just not sure what I have to do to fix that or change how it's being rendered. Also not sure what you mean with make fractal. You mean I should cut out something? So what I will do, copy that. So that works. Would be kind of weird if it wouldn't. And what they're doing is really just drawing another shape, and then that's then automatically cut out, as I understand it. To draw a shape with a hole, we need to draw the hole in a different clock direction as we draw the outer shape. We either draw the outer shape clockwise. Oh, okay. And the inner shape anti-clockwise, or the outer shape anti-clockwise. Oh, wow. So the direction in which these points are connected, that plays a role. So if I... okay. That's really fancy. So let's see. If I do I think about this correctly? If I would go clockwise here, so I would go from, what's the first point? The first point is, hello, first point is 7520. So that is this one here probably. No. Yeah. 7520. That's the first point here. So then the next point is 5060. So this point here, anti-clockwise. If I would switch these two and first go into the other direction, then it's not cut out. If I... And it's all one path. That's also worth noting. We're not closing anything. What happens if I call close path here? And I then call fill style equals red, and I call CTX fill here 2. And I have blue. That doesn't change anything. Oh yeah, I need to begin a new path. So if I call begin path, so that's how I can draw a red rectangle inside. But if I want to really cut it out, I have to not close the path and draw it anti-clockwise. And that's how I can cut out an element. Interesting. Oh, in index.html, try to play with meta name viewport. Oh, fractals are procedurally generated patterns. Okay, yeah, I'll give me a bit more time to grasp the basics. I do agree that that might be interesting, yeah. You mean I should change something about the initial scale here? Or are there like canvas, viewport, pixels? Is there something specific I should set? Oh, I could restrict the viewport, right? To not choose width, device width, and so on. Okay, so shapes with holes, we got that. Path 2D objects. As we have seen in the last example, there can be a series of paths and drawing commands to draw objects onto your canvas. Actually, there's one thing. Let's ask ChatGPT. I'm learning the Canvas API, and all my strokes, borders, are pixelated. What should I do? Change something about viewport? Let's see what ChatGPT has to say about that. It's thinking a lot. Oh yeah, the mismatching. Fix the canvas size. Canvas size and CSS are in line with each other. Oh, get the window device pixel ratio. Is that something that helps? Oh, yeah, that makes it crisp. So we're getting the device pixel ratio. Returns the ratio of the resolution in physical pixels to the resolution in CSS pixels. Oh, okay, so we adjust the canvas width and height to actually scale with my actual pixel density, so to say, okay. Scale the drawing operation so 1 unit is 1 CSS pixel. Huh. Now the browser isn't stretching anything. But I think it suggests this fix in case I had a difference in this width and height and this width and height, but I don't have that. My canvas has a width and height of 500, and that's not what I have here. Okay, yeah, I fixed it before and then I changed it back, I guess. So now, without setup canvas, it's not as crisp as with it. For crisp 1 pixel lines, use .5 offsets. Canvas strokes are centered. Yeah, we learned that before in MDN. At 1 pixel, sits half above, so we want to use 0.5 offsets. But this DPR change really made a difference here. Anyways, path 2D objects. As we've seen in the last example, there can be a series of paths and drawing commands to draw objects onto your canvas. To simplify the code and to improve performance, the path 2D object, available in recent versions of browsers, lets you cache or record these drawing commands. You are able to play back your paths quickly. Path 2D. What is the browser support? Everything green. Okay, so we would create a new path to the object. We could copy another path to the object or get some SVG path data. And we can use all the existing methods. So let's give this a try. If I comment this out, we now create, so now we no longer use the context like this. Instead, we create a rectangle by using new path 2D. And then we can call the rect method on it. And then we draw it by passing that object to stroke or fill. So I call rect, which is an awesome naming. And let's say I want to start at 100, 100, and then have, let's go 100, 100 here. And then I can use context fill style is purple, context fill rect. Yeah, okay. Do I think I will be streaming next week? Let me quickly check. Yeah, I think I will be streaming, yeah. So let's see, what did, let's draw what was pasted into chat. What could possibly happen? It's a nice curved line. Oh, it's the arc2 thing. Oh. Tangents to lines before and after. So we begin a path, we start drawing at 50-50, make a line to 150-50. So if I don't have, let me comment out this path 2D. We'll watch live. Yeah, see you next week then, Plim. And have a good rest of your day then. Till next week. So if I just move to line 2, we have like a hard corner, and with arc2 we get a nice smooth rounded corner. Okay, thank you so much for sharing this, binary boy, much appreciated. So that's what arc2 allows me to do. It allows me to connect these points, which would be connected by these lines, in a rounded shape, so to say. Got it. So let's move back to path 2D then, which I understand is the better alternative to using context fill rect and so on, since it has good browser support and better performance as they mentioned. So I think that is the better thing to use. What else do we have? If I create another object here, new path 2D, what do we have? We have arc, we have line 2, we have move to. So if I move to 50, do I still need to call context? Let's see if I still need to call begin path. And so move to that, arc, and then fill style blue, and fill. And No, I don't want arc 2. I want arc. Okay. Move to 200. 200. Do I have to call close path? Doesn't change anything. Oh, I don't need move to. I can just say 200, 200. Yeah, okay. Got it. Okay, yeah. So I don't need to begin path and close path with these, right? So if I create a path and sure, I move to line tool, let's see. Here it's calling close path to go back to the beginning, I guess. And do I need to call? No, there is no begin path. But I'm not seeing anything. Oh, I do see something. It's that green rectangle. Okay. Yeah. So it's just drawn on top of the other. But if I move to, let's say, 150, 150, and I then move further to the right and down, let's say, and then further to the left and up. And I don't think I need that. Oh, I do need that. Okay. Wait a second. Oh, yeah, I start there and then, yeah, makes sense. This is the start, right? Yeah. Okay, so I don't need to. And do I need to call close path? Don't need it here, right? Okay. Definitely takes some time getting used to, I guess. Using SVG paths. Another powerful feature of the new Canvas path to the API is using SVG path data. Yeah, so that we could like... That's another thing I don't know, by the way. SVG paths. I learned it a couple of years ago. But then again, use it or lose it. I did not use it, so totally not something I understand anymore. So I could say, explain this to me. What does this weird stuff here mean? Creates a new 2D path. Describes a shape. M1010 move to. Okay, M means move to. 1010 sets the starting point. No drawing. Horizontal line relative to the starting point. Because it's lowercase, it's a relative movement. Move 80 pixels to the right. Vertical down makes sense. Horizontal, and set closes it. So if I draw that, that's this square. And if I say, yeah, that's the start. Well, yeah, that is where I start. Let me actually comment out the other stuff here. So let's say I start 50-50 here. Whoops, that is my starting point. And then I draw a horizontal line relative. So I could go 20 pixels. I think, yeah, I like that because it's actually easier for me to understand in relative terms here. I can go 20 pixels to the right, or I guess minus 20 to the left. And that would give me a weird shape here. So let's go 20 to the right. So I started here, went 20 to the right. Then I can go vertical 80 down, or let's go 50 down. And then horizontal minus 80, let's go minus 60 and then close it. And that allows me to draw shapes like this. I believe this close path with the new path to D is used like an iffy in JavaScript just in case someone will use it to draw something using default API. Yeah, that makes sense. That makes sense. D3 has a line library that can do all your SVG paths for you when you give it an array of X, Y points. That sounds pretty good. I think D3 is probably next. I also did learn D3, but that is like 10 years ago, or no, 8 years ago, or something like that. I learned it back then to draw custom charts in Power BI. Yeah. Okay, let's go to the next part of the tutorial. Applying styles and colors. Okay, now the site is frozen. And here we go. Okay, and it's frozen again. What are they rendering on this site? Okay, I can hardly navigate. Oh, it's all the demos loading. Well, maybe they should lazy load. Well, so colors, fill style, stroke style, that makes sense. When you set stroke style and or fill style, the new value becomes the default for all shapes. Yeah, so again, that would have been nice to learn early on. I found out by now, but it was kind of confusing that it was applied as a default for everything. For every shape you want a different color, you will need to reassign. Sure. So we can assign color names, hex codes, RGB, probably also HSL and so on. A fill style example. In this example, we once again use 2 for loops to draw a grid of rectangles. Oh, that's pretty nice. So yeah, they're dynamically generating the colors here. And then just drawing a bunch of rectangles where the offset continuously moves. So, what does cursor suggest here? Let's see what that gives us. I want to find out. Oh, wow. That's not exciting. So what they are doing, can I also create an object with new path to D and then set the fill style there? No. Okay, so I still set context fill style. And I set that to RGB I times 10. So that will get, we start at black. And then we add more and more green and blue over time. Will probably not look as nice as what they are doing, but I want to see what we get. Yeah, and then we just do this. So I got the same, just darker. And actually, let's make those rectangles a bit bigger. And let's start. Whoops, didn't mean to do that. Let's actually start at some offset here. Okay, and let's not start at black maybe. So let's say we use math floor. And then we have, oh no, I meant, no, I'm wrong. I want to, what are they doing here? Math floor, and then they're using the highest value for the color, minus 42.5. So what if I just add something here? What if I just add 10? Oh yeah, don't need parentheses, of course. So let's add 20. So now now this is brightening up. Okay, yeah, that's quite nice. So yeah, stroke, fill style and stroke style. Transparency. I can imagine the chaos if attempting to vibe code canvas animations. Oh yeah. Though, there was this guy, Levels.io, maybe you know him, who vibe coded that that flight simulator, if you want to call it like this, using Three.js, which, well, I don't know about the code quality. I guess it had a couple of bugs. And I don't think it's online anymore. But it kind of worked. He got something to work. Sure, there were some cross-site scripting attack issues, as far as I know, during the development process. But yeah, I guess you can get something to work. I just imagine it's super hard to get exactly what you want, leave alone performance and security issues. In addition to drawing opaque shapes to the canvas, we can also draw semi-transparent or translucent shapes. This is done by either setting global alpha or by assigning a semi-transparent color. Yeah. Global alpha. Okay, yeah, I guess that makes sense. The Windows logo. Line styles. There are several properties which allow us to style lines. Line width, line cap, the appearance of the ends of the lines. Line join, the appearance of the corners where lines meet. I'm interested what line join will give us. Oh, we got some examples coming up. Great. Meter limit. When two lines join at a sharp angle to let you control how thick the junction becomes. Line dash. Okay, line width. Sure, that is the line width, unsurprisingly. Line cap. But the ends of lines are squared off. At the endpoints round, the ends of lines are rounded. So we can see that here. Rounded. That is but. And what was the last one? Square. The ends of the lines are squared off by adding a box. Okay. Line join, round, bevel, and meter fills an additional triangular area. So yeah, so here we got round, bevel, meter. And we do that by simply setting line join to whatever we want. So if I, again, if I draw a little path, and I move to 100, 100. And then I go, let's say, to the right, and I stay on that level. And then I stay on the x-axis, but I go down. And then I go to the left. So I'm drawing a rectangle again. If I then set path context line. So not line style, what is it? It's line join. Line join equals round. And I set stroke. I want to stroke that. And I'll give it a line width as well. So line width is 10 and stroke style black, sure. Now I got some nice rounded corners. And is that the thing where I should pick like a, no, I don't think I should. There was something different, right? So, okay, that's how I can get rounded corners. I can also call close path to close that shape. Okay. As you've seen in the previous example, when joining two lines with the meter, is it meter or mitre? I don't know. The outside edges of the two joining lines are extended up to the point where they meet. For lines which are at large angles with each other, this point is not far from the inside connection point. However, as the angles between each line decrease, the distance increases exponentially. The meter limit property determines how far. Okay, show me how it looks like. Okay, so it tries to essentially generate a nice, how do you say it? It kind of extrapolates kind of these lines, you could say, to have like a nice angle. But with the limit, you basically tell it what the threshold for that is, so to say. Okay. Line dashes. The set line dash method and the line dash offset specify the dash pattern for lines. Okay, so what are we doing here? We have set line dash. I want to try that too. Context set line dash. What is that? That is segments. Okay, what does this do if I have 10, 10? What if I have 10, 1? What are... accepts a list of numbers that specifies distances to alternately draw a line and a gap. Oh, okay, that's how long the line is and the gap is. So now the line is twice as long as the gap. Yeah, makes sense. So if I set this to 15, the lines are even longer. So that's set line dash. And line dash offset, what's that? Specifies the dash pattern for lines. Sets an offset where to start the pattern. Yeah, so I can say context line dash offset 10. And now I got my rounded corners back, because maybe you noticed without that, it started here and therefore broke the corners, and that affected all the corners. If I offset that therefore so that the first corner, so to say, is not broken, now I got back my rounded corners. Makes sense. Looks like Path2D improves performance very much when creating games editors. Yeah, they wrote that it has better performance, so I guess it's the standard you should use. I don't know, it looked like it had decent browser support too. Gradients. Just like any normal drawing program, we can fill and stroke shapes using linear, radial, conic gradients. We create a canvas gradient object by using one of the following methods, and we can then assign this object to the fill style. Okay, fill style and stroke style can be gradients. Ooh. So if I create a gradient like this, and I then set my context fill style to gradient, and I call fill, shouldn't I see a gradient? It feels like whenever you try something new here with the Canvas API, at first it doesn't really work. Creates a linear gradient object with a starting point and an end point. Do these points... Oh, they need to be inside, maybe. So if I... So I guess they need to be inside of that thing. Well, that would have made sense, but it's not the case, as it seems. Create linear gradient. Oh, maybe I still need to assign a color, though. Oh yeah, add color stop. Okay, reading the tutorial helps. Color stop 0, color stop 1. Haha! Here we go. So now let's actually use purple. Get a nice gradient here. Awesome. Yeah, radial gradients, conic patterns. In one of the examples on the previous page, we used a series of loops to create a pattern of images. There is, however, a much simpler method we can call create pattern. Creates and returns a new canvas pattern object. Image is the source of the image, that is an HTML image element, an SVG image element, another canvas element, or an what's an off-screen canvas? Is that, I guess, something where I can draw off-screen to load it later? When using the canvas element or the canvas API, rendering, animation, and user interaction usually happen on the main execution thread of the web application. The computation relating to canvas animations and rendering can have significant impact on application performance. That's why I can draw off screen. Rendering operations can also be run inside a worker context. Okay, got it. So I could draw something, render it, and then like present it when it's done, I guess. Something else I have to dive into. We can use a video element. So I know that you can actually also like play a video on a canvas, and that allows you to do crazy manipulation stuff of the video frames and so on. I read that when I had a look at Remotion a couple of weeks ago. But that's a different topic. Anyways, okay, so we can draw patterns. Shadows. Using shadows involves just 4 properties. Shadow offset X. Okay, I want to draw a shadow. So shadow offset X, Y, shadow blur, and shadow color. Okay, so if I go here and I say shadow, offset X is 5 and Y is 5 and blur is 10 and then it's black. Now I got a little shadow here. Ooh. And I guess if I use something like purple and I ramp up that blurriness, it looks more like a glow. Yeah. Shadowed text. We can, again, we're learning about something, text, which wasn't really mentioned before, but okay. So how are they rendering text here with fill text? Okay, so we can also say fill text. Hi there. No, I did not want to do that. Thank you. And fill text also needs X and Y coordinates, I guess. And then we can set the font. And now I got my text here. And it's affected by the same styling, of course. because we learned before that this applies to everything. So all these styles I'm setting, which makes sense. Pixie.js, the HTML5 creation engine. Create beautiful digital content with the fastest, most flexible 2D WebGL renderer. So I guess that's the next level, where you don't dive into the nitty-gritty details of the Canvas API yourself, but instead you got a nice framework or library to work with. Definitely also looks interesting. Thanks for mentioning it. I'll make sure to look at that as a next step too. Because again, I really want to get into that stuff. Also into 3D rendering then and so on. I want to get into that so that I get a better understanding for what's going on or how you can use these APIs. Even if I then maybe don't use them all the time. But I don't want it to be a black box. Canvas fill rules. When using fill or clip, whatever, I don't know what clip does. Guess it's for masking or something like this. You can optionally provide a fill rule algorithm by which to determine if a point is inside or outside a path, and thus if it gets filled or not. This is useful when a path intersects itself or is nested. Yeah. Okay, so I guess that's if you draw like these weird shapes that cross themselves. This could help you control what's filled and what not. The even-odd winding rule, sure. The even-odd rule is getting used here. We're drawing an arc on top of itself. And how would that look like without that? I also don't know why they don't use path to do it 2D anymore, but sure. So let's get rid of all that stuff. If I don't use even odd, I mean, if I just use fill therefore. Okay, now it's one circle, and with even odd, it's kind of cut out. Because with even odd, it looks like, well, what's the official definition of that? Oh. Is an algorithm implemented in vector-based graphic software, like the PostScript. Unlike the non-zero rule algorithm, this algorithm will alternatively color and leave uncolored shapes defined by nested closed paths. This rule determines the insideness of a point on the canvas by drawing a ray from that point to infinity in any direction and counting the number of path segments from the given shape that the ray crosses. If this number is odd, the point is inside. If it is even, the point is outside. So if we draw a ray from this inner circle to infinity, we meet one element but doesn't that mean it's inside and should be filled? Because one is uneven. Even odd on the left, non-zero on the right. So yeah, this hits one point, one shape. In each case, an arrow shows a ray. In the even odd case, the ray is intersected by, oh, it's two lines. Okay. So here, if we have like this here as the center, whoops, here, and we have that ray, it has two lines it crosses, so therefore this is even and is considered outside. Okay. Got it. Oh, now we learn about drawing text. This is super slow. This site is super slow with all these examples. Okay, this one's better than the one before, but fill text, stroke text. Strokes are given text at the given XY position, optionally with a maximum width to draw, optionally with a maximum width to draw. So max width means we have a box for the text. Is that it? So if I bring back that text here, like this, if I draw it like this, it's high there. Now if I pass that third argument, like 50, yeah, okay, so that's basically a box, and we then like squeeze the text into the box, or I guess have it expand. Okay, but it does only expand as much as it needs to. Okay. So I guess what we could do is we could have like a box, new path to D, a rectangle, 200, 200, and then actually I don't want to have a square. I want to have a width of 200 and a height of, let's say, 50. And we call context fill box. And then I want to have the text inside of that. So I would go to 300 and 225, I guess. Okay, actually, I don't want that box to fill now that I think of it. I want to stroke it. Oh, yeah, I want to start at the beginning of the box, actually, with the text. So let's say 210 to have some spacing. And then probably also a little bit. Oh, it's going up, so we want to be almost at the bottom, of course. So we want to be at 240. Yeah, that's how I could put that in there. And it would 245. Well, 242 to make room for that font. And yeah, okay, so that's how we could do this. And then, of course, we could also say like a line with 10, 20. Oh, yeah, and do that before we stroke and make that thicker. Yeah, okay. Got it. So that's text, styling text, font, text align, text baseline, direction. Yeah, that all makes sense. Using images. Yeah, so we saw that before, that we can draw image elements, SVG elements, video elements, all kinds of stuff, but I don't think I want to dive into that right now. What do we have about transformations? Okay, saves the entire state, restore. Canvas states are stored on a stack. Every time the save method is called, the current drawing is pushed onto the stack. So that's interesting. The transformations that have been applied, I haven't learned about them yet, but I guess I'll do. Translate, rotate, and so on. They are part of the drawing that is saved, or part of the drawing state. And then all these stylings that have been applied. And clipping path, which we'll see in the next section, composition and clipping. You can call save method as many times as you like. Each time the restore method is called, the last saved state is popped off the stack and all saved settings are restored. So here we draw a rectangle. We save that. So if I call context save, does that remove it? No, it's still there. But if I then change something, if I then, let's say, draw another text, hello there, at a different position, that's here. If I then call context restore, what does, yeah, I guess, I understand, I get that we save and restore, but what does this actually change? Oh, if I operate only on the context, of course, I might be editing it. Draw a black rectangle, save, make changes. Draw a blue rectangle, save, make changes. Draw a 50% white rectangle, restore. So if I take this code here, without restore, I have this. With restore, I have the same. Oh, but now, oh, I restored, okay, so I restored the settings. If I now draw another rectangle, it looks like this. If I remove restore, though, I won't see it, or I do see it, but it has a different color because I haven't restored the settings. The fill style is white. That's why this inner rectangle is white, I guess. If I restore, on the other hand, I restore this fill style because that was when I called a save thereafter. So if I maybe make that a bit clearer, if I set this to red, now the inner rectangle is red because I reset that to that red state. Okay, got it. Okay, the top drawing state is removed. Okay. Translate is used to move the canvas and its origin to a different point in the grid. To move the canvas and its origin. Okay, moves the canvas and its origin on the grid. So I move everything on the canvas then. It's a good idea to save the canvas state before doing any transformation so that I can restore. Okay. So with all that drawing here, if I call translate on my canvas here, and I move it by 100, 100, I guess it moved to the right. It can't move down due to my CSS code on this page, I guess. What if I rotate? Do I need to call something? Context rotate. Maybe I need to change my CSS a little bit. Let's remove flexbox in the surrounding container. Not sure if, whoops. To first rotate a rectangle. It's not really rotating anything here for me. I wonder why not. So if I copy that code, we save initially in that code so that we can restore. If I do that, save, fill style, draw a rectangle, rotate. Okay, now it works. So we we draw a rectangle, we rotate. We draw another rectangle, and my understanding is that the same rotation gets applied, which is probably why these two gray rectangles are similar. So if I change that, No, it's just the first one. So if I comment this out for now. No, it's just applied to what came before, as it seems. But why do I call restore here? Which difference does this make? If I comment this out, looks like this. If I comment this in, looks like this. Does it make a difference for the next thing I draw? Rotate from rectangle center. So I got another one. Okay, without restore, this new rectangle which I'm drawing is also rotated. Oh, I see. This rotate affects this rectangle. Then I draw another one, which is affected by the same one. The first one wasn't affected because rotate came thereafter, but these two are. But if I call restore in between, then I restore the settings after this rectangle, so I get rid of the rotation because initially is saved before changing anything. So we go back to this state, and therefore this rectangle then is not rotated. Makes sense. Okay. Oh, it's 7 p.m. in Germany already. So I gotta go. I know, definitely a different stream, maybe a bit boring, not sure. But maybe also interesting to see how I approach something like this. Definitely a topic I wanted to get into. Definitely a topic I have not fully understood yet, but I have a better grasp. In case you want to watch it again, you can on my second channel, Maximilian Extended. You can see all the past VODs. I plan on streaming again next week, so hopefully I see you there. Probably not again the Canvas API, probably something a bit more exciting, but we will see. I wish you a great evening, day, whatever it is for you. And thanks so much for tuning in and being part of this stream. Wish you all the best. Bye.